Apache Kafka is a distributed stream processing software developed by LinkedIn and written in Scala and Java. In this video, I want to focus on the basics on Kafka. I want to talk about the components of Kafka, how it works, and finally, spin up our own Kafka cluster on Docker and write some applications, some producers and some consumers using Node.js and Kafka.js. If you're interested, stay tuned. You have no idea how many comments I got to make this video, right? Everyone is asking about Kafka. Ever since I made the video about RabbitMQ and publish subscribe, it's just flooding with Kafka, right? It's just I know at some point I wanted to make this video, and here it is. It took a lot of research. This is a very interesting tech. So if you're interested, let's just jump into it. As I go through the table of content or the agenda, you'll start seeing time codes where you can jump into the interesting part of the video, right? The first topic is Kafka Components. This is the longest topic, really. I'm gonna break down the components of Kafka. I'm gonna explain how Kafka actually works. I'm gonna introduce one component at a time as I explain the necessity of this component. I'm not just throw all the components and just explain it, because I started that way and it got confusing, really. So I started with one of the basics, brokers and producers, consumers, and we'll slowly build up until ZooKeeper and all that stuff. So then obviously we're going to go an example because, yeah, right, I need to see this working, right? So we're going to spin up our own Kafka cluster. We're going to spin up a ZooKeeper because you need that stuff. And we're going to write our own code, Node.js and producer and consumer, and create a topic and do all that jazz, right? So with that just an example. And then finally, we're going to talk about the pros and cons of Kafka. Because guess what? Nothing's perfect, right? And we're going to summarize the whole thing. Let's just jump into it. If you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing, hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into Kafka, guys. The first component of Kafka is what we call this Kafka server or the Kafka broker. And that Kafka broker is basically the first server that users interact with. And since it's a server, right, it's listening to some TCP connection to accept connections, right? That's how RabbitMQ work. That's how web servers work. That's how pretty much any networking application works. You have a server, gotta listen on a port. That's the default port for Kafka. It's 9092, and it's called a broker. And there's magic inside the stuff, right? We're gonna go into it. And there are two pieces of abstractions here, which we call the producers. This producers produce content, it publishes content to the broker, and then consumer consumes content from the broker. Okay, so it seems simple, right? It just seems very simple and to the point, right? Guys, if you're interested to know like more about the publishing, pub subsystem versus queue and all that stuff, I'm going to reference a video that I did just talking about pub sub, right? Because I'm going to glance over the idea of pub sub because I dove deep into that technology in another video. So go and check that out if you're interested. But here's the thing, right? So the other abstraction in Kafka is essentially the connection, right? And then you have obviously a producer connect to the broker using a TCP connection, and that's a raw TCP connection, so it's bidirectional. So broker can send information to the producer, and the producer can send information to the broker, and so on. Consumer is the same thing. You establish this TCP connection, right? There is a protocol. I couldn't find the details of that protocol, to be honest, on my searching, so I'm not sure what's the protocol here. Maybe it's just custom binary TCP. Okay, and here's the thing. So once you establish these TCP connections, which we know how it works, right? We talked about TCP. I'm going to reference it here. Just talk about just general TCP connection. Here's the concept. There's a topic, right? Topics are basically this logical partitions where you write content to, right? So it's such as logical partitioning of data, right? And then when the producer writes, it has to specify which topic to write to, okay? So, hey, I want to write message A to topic A, right? That was bad. I want to write message hello to topic A, right? Consumer, hey, I want to consume topic B. The broker will send the messages to the consumer, right? And so on, essentially. So that's essentially these two pieces. So topics, consumer, producer, broker. Sounds good, sounds simple. Let's complicate it a little bit. So we're gonna zoom in here to the actual topic. So I made like a little bit of space here. So I have a topic called users in my Kafka broker. And then I'm gonna talk about how producing work, how the Kafka producer works, right? So I'm gonna send an example here where, hey, I am producer, hey broker, because we established the connection, right? Now we send a request, and that request says, hey broker, publish John, the string John, to users topic, okay? And it did, right? It just go take that string and then appends it to the topic, okay? And then very interesting, the word append. We're gonna explain the concept of appending later in Kafka, which is very critical thing here. Okay, you can always add stuff to Kafka. You cannot delete stuff. It's always append only, right? So it's just like, hey, shove that. That sounds simple. All right, let's publish something else. Publish ed to users. It goes into the end of that, and each message is referred to by essentially the topic and the position, right? And the position is very fast access because, hey, go to the position number 0, that's John. Go to the position number 1, that's Ed, right? So that's very simple to go and index very quickly to that, right? Because everything is sequential essentially. So here's a topic with a bunch of users, bunch of data, and let's say I'm gonna produce another message and say, hey, Leo, publish Leo to users topic, and append it to the end. And you can start seeing that the topic is getting larger and larger and larger and larger, right? And we're going to talk about what we're going to do with this, right? Because we as software engineer and database engineer have solutions to these kind of problems, things that grow really large, right? So what happens if I consume? So consumer says, hey, I want to consume the topic users, right? Let's go ahead. What's going on there? So if this is the first brand new consumer, based on configuration, it's going to read from position number 0. So it's going to get John. So the moment you get John, it's going to get the next one, which is Ed, and so on. So the moment start polling information, consumer is actually polling for information. This is not a push model, okay? But we're going to talk about that in detail later on the video, right? So the consumer just start asking for more, asking for more, asking for more, right? Unlike RabbitMQ, where the broker pushes information to the consumer. Yeah? So that's a very important thing to distinguish here. Okay, sounds simple, still simple, Hussein. That doesn't sound complex. How about we dive deeper? All right, now we know, right? Topics grow large. What do we do, guys, with databases when they grow large? When their table goes to millions, millions, millions of rows? We do sharding, right? Because it says, okay, customers from number 1 to 100,000 goes to this table, to this database. From 101,000 until 200,000 goes to this table in this database. And you guys, consumers or database clients, please know, if you know we're querying customer number 100, you know to go to database A. If you're querying customer number 205, 200,005, then go to this database. So that's essentially the concept of sharding. And Kafka just borrowed that concept, right? Because we want to distribute the data, because queries get slower and slower if the data is large, right? So what you do is like, hey, let's shrink it up, okay? And here's what we're gonna do. We're going to do the same thing. And Kafka called them partitions. The same concept. It's sharding, essentially. And what we're going to do is that, hey, this user is so big, right? So let's say I'm going to create 2 partitions. Partition 1, user with first names that start from A to M goes here. And users from N to Z go to partition 2. Well, that sounds simple. That doesn't sound hard. And now we're working with a little bit manageable data, and then these can grow as independently, right? These can grow independently, and that's cool. All right, so this is simple, but you know, guys, the concept of for sharding, and we didn't talk about sharding in this channel. I gotta make another video about it. But the moment you introduce sharding or partitioning, then those guys suffer, right? Because now they have to know what the heck is a partition, right? They need to understand what partition, not only what topic to write or read from, they need to understand what partition to read and write from. And that kind of sucks because that introduced complexity to consumer and producer, and we're going to talk about that later. All right, so what happened now if a producer want to publish nadir, a user nadir to users, to topic users, and on partition 2, we just talked about it. Now we know that, hey, nadir is in, and in is in between n and z. So yeah, so the producer have to figure out which partition to publish, which kind of sucks, but it all because of the scalability. We're gonna suffer, right? Life is suffering, as Jordan Peterson say, right? It's all suffering. You cannot escape it.
Well, you accept it. That's what life is like. It's suffering. Life is suffering. Yes.
So yeah, so nadir, we'll go to partition 2. Let's go ahead and just write it to partition 2. That sounds simple. And here's what happened. The moment you write it this, now you get a new position, right? And that position is returned to the producer. Say, hey, by the way, the current position on partition 2 is 4. Okay, 0, 1, 2, 3, 4. And then consumers, let's say, hey, I want to consume partition 2 on position 0, right? And that will start reading that. And if we want to, and it will update its position until it reaches the latest data, essentially, and says, okay, there's nothing more to read because you reached the end of the partition. And you can see how fast this thing is because you only work with indexes. You work with positions and partitions. And you don't really say select star from topics where first name equals Sarah, all right? You don't do that, right? This is not relational Postgres database, right? You don't use Kafka to do ad hoc queries. You use it for fast writing and distributed of events that happens, right? And we're going to talk about the benefits, essentially, all right? So nice. Before we jump into the next abstraction in Kafka, we need to talk about this difference between queue and a pub-sub, right? So a queue is essentially when a message is published, right? It is published once and it is only consumed by one consumer, right? And that makes sense, right? It's a queue. You publish it to the end of the queue, some consumer pulls it or pops it from the queue and consumes it, and it's gone from the queue, right? Nobody else can consume it. So that has its advantages, and you want to do that. RabbitMQ is great for this, and this is really good for like job execution. Hey, please execute this task. You want one of your workers to pull the task and execute it. You don't want someone else executing the same task twice. That's bad, right? Some things, some applications, some use cases, you want to execute only once. And queue is great for that, okay? And the other concept is a pub-sub. It's like, hey, I want to publish a message once, but I want it to be consumed by a lot of users, okay? A lot of consumers. The same message, I want to broadcast it. I want to multicast it to multiple consumers. I don't want to remove it from my data, right? From my queue. I can't say queue, it's something else. But I don't want to remove it from my source, right? I want it just to broadcast it. And there's a lot of use case for this as well, right? Hey, another example, we talked about that where, let's say YouTube, right? I want to publish a video, right? You upload a video. The moment you upload the raw video, what you want to do, you want to multiple services to consume this raw video. Like one service could be the compress service, right? Take the raw video and do some stuff on it, right? Compress it. The other video, take the raw video and make it into multiple codec, right? So like 480p and 1080p and 4K, just encode in different formats for mobile and streaming, right? Another one is like, hey, the copyright service, let's pull that up, pull the raw video and check if someone is like infringing on some content ID, right? If someone is using other people material, or there's a music that you can't really use, or something is offensive, right? So that's an example of a pub sub architecture where a pub sub is useful. Okay, so pub sub, queue, each has use case. Kafka came in here in the picture and says, we want to do both. And that's bold, man. That's bold question, right? And here's what RabbitMQ did, and I believe they messed up with this. RabbitMQ started as a queue. It's the name, message queue, Rabbit message queue, right? They started that. But then they said, oh, but people wanted to do PubSub. And obviously you cannot do RabbitMQ PubSub, but they invented the concept of exchanges, I believe, right? I might be wrong, to kind of hack their way to introduce this feature, right? Which made it really complex and make the system really weird and awkward, okay? Kafka answered this question from the beginning, from the get-go, from the design. They built a system with those two in mind, okay? And the answer to this was consumer group, right? And this is one of the most confusing, to be honest, abstraction in Kafka. It took a while for me to really understand and nail this down. So I'm going to explain consumer groups right now. All right. So consumer groups were invented to do essentially parallel processing on partitions, right? Because now consumers can read from a partition. You're aware of the partition, right? And that's bad. So the consumer group can actually fix that problem. Remove the awareness from the consumer of a partition. Another benefit is it can kind of run and consume parallel data, like consume parallel information from multiple partitions, and we're going to talk about that. So let's assume we have here a consumer group. Let's go to group 1. I'm going to add a brand new consumer, just joining the group, right? So you create a new consumer, and then you say join group. And the moment you join the group, and if you're the only consumer, tough luck, man, because you are now responsible of all partitions in this topic, because now you subscribe to topic users, all right? And that topic has 2 partitions, and if it has 7, you are responsible for the 7 partitions. And what does that mean? It means that any time you start consuming, right, you will get essentially a message from partition 1, right? A message from partition 2, or if there is existing partition 3. So you start receiving messages from both partitions. And that's not bad, okay? That's okay, because if you're a good consumer and can handle the load, you can just essentially receive messages, and you don't really care which partition this is coming from, right? So what this is what really interesting. The moment you add another consumer to the group rebalances. It says, oh, okay, consumer 1 was really overloaded, so let's remove partition 1 and give you partition 2, consumer 2, all right? And here's the thing. Each partition have to be consumed by one and only one consumer, right? You can have one consumer consumes 2. Oh, that's confusing. You can have one consumer consuming 2 partitions or 3 partitions or 4 partitions, but one partition better be consumed with one consumer. That's the rule. And consumer group makes sure of that, okay? So now we have the rule, that's good. And here's the thing, consumer 3 cannot join the group because they say, hey, you don't have anything to do, man, right? So and the moment you do that, something interesting happens, because now those 2 can work because they are different processes, I would assume, right? It doesn't have to be, but you can put them in different processes. And the moment you do that, you will start receiving, right? You can start consuming these two partitions in parallel. And that's really cool concept, right? And the moment you do that, right, it starts consuming these partitions, you will act essentially like a queue, right? The system becomes a queue. And you say, Hussein, how, right? And here's the thing. If partition 1 and consumer 1 is responsible for partition 1, it will only receive data from partition 1. And the moment it consumes one piece, that's it. The position is updated in the group. It says, oh, partition 1, 0, position 0 has been read. Move on. Okay, the moment you read 1, it goes to 2 and 3 and 4 and 5. It just keeps going, right? That's by default. Obviously, you can fix the position to go back and read, but by default, if you just left the group as it is, it will act like a queue, right? The moment you read John, that's it. It's almost like popped off the queue, and you start reading the next information and the next information, right? And consumer 2 will never be able to read John because it's responsible for partition 2, right? So we just achieved the ability to do a queue, which is amazing, right? So consumer group, if you want to act like a queue, put all your consumers in one group, and immediately you will become a queue. The system becomes a queue, right? Because what will happen is you will each consumer in the group will be responsible for one partition, and that partition will never be seen by any other consumers in that group. So the moment the consumer read one message, it's gone, right? You can read the second message, it's gone. The third message, it's gone, right? When I say it's gone, it has been committed as read. It's still in the system, right? But it has been committed as read. You still can do stuff and go back and read it, but out of the box, it will just normally work, which is powerful stuff, guys. Right? So that's how you do it. How do you queue? If you want to do a RabbitMQ setup, put all your consumers in one group and ta-da, right? If you want to act like a pub subsystem where the message is broadcasted to every consumer, simple. Each consumer goes into its unique group. And that's okay because a partition can be consumed by multiple consumers in different group, right? Because the partition is a group dependent, right? And that's okay, right? So that's how a consumer group essentially act, right? And what do we get as a result? We get parallel processing for free, which is amazing, right? Because if you have like multiple consumers in one group, they can start reading multiple partition in parallel and do so much coolish stuff. All right, almost at the end. Distributed system. So yeah, that's another piece of the Kafka puzzle, right? It's a distributed system, but how, right? Well, distributed system means take the broker and copy it, right? And make it a leader-follower system, right? Where we have one leader where it takes all the requests and one follower where it just reads from the leader, right? Or a kind of master-follower kind of a configuration, right? So let's do that. Well, let's gonna spin up another Kafka broker. We're gonna listen to another port. That sounds easy, right? And here's what we're gonna do. We're gonna copy stuff. And when you copy, we're gonna mark things as leader and follower, right? So if you copy everything, let's copy this user's topic. This is the major broker, right? And the moment I do that, I start copying partition 1, copying partition 2. I'm done, right? But here's the thing. How do I know which broker responsible is the leader and which broker is the follower? You need a system that tells you that, right? We're going to talk about what the system that is, right? And here's another concept in Kafka. It says like, no, in Kafka, we don't want a leader broker and a follower broker. No, I want that at a final level. I want it at the partition level. I want you to be the leader I want this broker to be the leader of partition 2, but this broker the leader of partition 1. And that's cool because now if the whole broker went down, you don't lose your entire data, right? Because you don't have one master or one leader, right? The leader is responsible for multiple partitions essentially, and that's good for partitioning and having the ability to do a distributed system. So we're having distributed at the partition level, but where's this data stored, man? Where is this concept stored? That broker 9093 is the leader of partition 2 on topic users, and 9092 is the leader of partition 1 on users topic. And where is that information stored? Meet ZooKeeper, the biggest disaster in Kafka. Again, this is a controversial topic. A lot of people like ZooKeeper, right? I personally did not use it, but a lot of people do not like this technology because it caused a lot of pain than good, all right? But essentially what ZooKeeper does is it just herds the cat, as they say, right? Just says, hey, you are the leader. You are the leader. Follow the leader, leader. Follow the leader. That's what it does, right? Okay, and let's go an example, dude. Let's go through an example. Producing, how do we produce in this configuration where we have ZooKeeper, right? And here's the thing, it's just like, hey, when you connect to create this bidirectional connection from a producer to the broker, you actually, what you do is that you ask, before you submit something, you ask, man, who is really the partition leader of the thing I'm about to write to? And then you write to it, okay? So let's say I'm about to write Zane as a user Zane to users topic, and on partition 2, because I had to figure out what partitioned by doing this simple check at my end, a little bit complex, but sure, why not, right? And then we'll just like shove that information, says, hey, I want to write to that. I have no idea who's the leader. And here's what I am not sure about, and someone can correct me in the comment section if you guys know, right? I'm not sure if the producer is aware of who is the partition leader, right? Because you gotta write to the leader. You cannot write to a follower, right? You can only read from a follower, right? If you were writing, you better write to a leader, right? But how do you know, right? So what I'm not sure about is the producer. Does the producer know that, partition 2? Let me query. Partition 2 is actually 9093. Let me establish a connection to 9093 and let me write to 9093 because that's the partition leader. Is that the case? Or is the other case where, hey, any broker, and I think it's the latter, any broker that I'm connected to, 9092, please write this message to producers partition 2. And those guys gossip between each other. That's another word. The ZooKeeper actually, they use a gossip system to determine who's the leader. And they talk to each other. So the brokers gossip between each other and they say, who's the partition 2 leader? Okay. It's like, yeah, it's me, 9093. Let's go, right? So they will communicate between each other and they will write Zane to the correct partition, to the correct broker, to the correct topic, right? Once it does that, what happens is, wait a second, we just wrote to the partition 2 on 9093. The follower need to read that information and then just copies it, right? That's what we do, right? Seems good. How about consuming, right? I want to consume topic users on partition 1. Again, with a consumer group, you can avoid saying partition 1 if you want to, right? Because what happens essentially is the group will assign you a partition, right? And then you'll be responsible for that partition and you can just read. You don't have to specify a partition, right? And we're going to show that by an example. Sweet, right? So, hey, I want to read partition 1. Well, you can either read from a leader, and it depends on whatever is available, and this depends on Completely depends on ZooKeeper and how whatever this algorithm is, right? And then you can hit another follower node and read the same information because they better be the same, right? Essentially. Sweet. Let's jump to an example, guys. Here's what we're gonna do. All right. So the first thing we're gonna do is we're gonna spin up a ZooKeeper instance because even if we're gonna work with one broker, unfortunately, we need ZooKeeper. I have no idea why. It's just baked into the technologies. It's baked into the tech, and the whole thing is just they need it, right, to start, just to start, right? So you need ZooKeeper to just herd the cats, as we said, and then we're gonna spin up a Kafka cluster, single Kafka cluster, both of them on Docker. I don't want to pollute with your machine with installation and all that stuff, right? And guys, I didn't use the Confluent quick start, whatever it's called, Docker Compose. To me, it was very complicated. It needed just 8 gigabyte to install that stuff, and they have like Kafka Connect and streams and the command line. I don't need any of that. I'm just showing you guys how to do Kafka and ZooKeeper. So I'm just spinning up just those 2 Docker containers. So that's how I'm gonna do it in this video. All right, and we're gonna learn how to create a topic. We're gonna create the user's topic, and we're gonna use this beautiful Node.js package for a library for Kafka.js, right? I checked out another library called the Node Kafka or Kafka Node. It wasn't great, really. It was so buggy and didn't have promises. So just out of the box, it's just I had to just work with something else. And thank God I found this Kafka.js. So we're gonna use that. We're gonna create a producer. We're gonna write a message to the user's topic. And then we're gonna write a consumer to consumes from the user's topic. Let's just jump into it. All right, guys. So let's start by spinning up a ZooKeeper Docker container, right? So the first thing we're gonna do is let's make sure you have Docker. Go and install it for Mac or Windows. That will work. The moment you can do Docker run hello -word, and you can just see that there is a result here, hello from Docker. You are good to go, sir. You can start this tutorial right now. Let's spin up a ZooKeeper instance. And to do that, we do Docker run. Okay. And then when you do Docker run, the first thing we need to do is give the container a name. That's always a good idea. So how do you give a container name? -- name. We're going to call it ZooKeeper. Okay. And then since ZooKeeper running on a port, you're going to expose that port outside to my machine so we can communicate with it, right? There are better ways, but this is just a tutorial, right? So we're gonna do it the hacky way, as they say, right? So what we're gonna do is just expose the port, which is the port of ZooKeeper, and the port of ZooKeeper is called 2181, okay? And we want to expose port 2181 that is in the container to the same port on my machine because I don't have ZooKeeper running, so this will work, right? So that's the second step, right? And finally, what we're gonna do is just pull from the image that's called ZooKeeper and then run. It's very simple. We'll start downloading the image if it doesn't have it, and then we'll start running, and just like that, we have ZooKeeper running. That terminal is now occupied. I know, guys, you can do -D and make it detached, but always, if you know me, I like to have the terminal and I see what's going on, right? So that terminal is now occupied with ZooKeeper. Let's spin up another terminal. So what we're gonna do is shell, new tab with profile, and let's do, now this is ZooKeeper, we can tell this is ZooKeeper, which is nice, right? And now we're gonna run Kafka. And that is, now you're gonna have to copy this, right? I'm gonna go through the command one by one, but I'm gonna leave the actual command in the description below, so you just copy and paste it, right? But here's what you do: Docker run, same thing, and obviously we need name the container. Let's call it Kafka, right? That's not hard so far. So far, simple. Right. Another thing we need to do is expose a port because again, Kafka is running on a port. And what's the port for Kafka? It is, remember guys, it was 9092 and then obviously 9092. Okay, so I'm gonna expose the 9092 that is running in the container to my machine 9092. So if I say husseinmac, which is my machine name, that's how we're gonna communicate with the broker, right? And that will be mapped to the internal one. I can call this whatever I want, but I'm gonna call it the same import because I don't have anything running on 9092. What else? Now we're gonna start writing the list of environment variables for the container to start spinning, because Kafka, what does Kafka Broker needs, guys? It needs the ZooKeeper instance. And what is the ZooKeeper instance? It's very simple. We just do -e, which is environment, and here's how you specify the ZooKeeper instance. It's called Kafka ZooKeeper underscore connect, and you say equal, and just by doing that you will specify the ZooKeeper instance. And do you guys know, right? We just spin up ZooKeeper on port 2181, so I'm gonna do, it's essentially husseinmac, which is my machine, colon 2181. So that's the first environment variable. What is the second environment variable? Is when we do this Kafka broker, you need to expose the address of the broker to your client, like producer and consumer. How do the brokers do that? So you have to tell them, and the reason is you have to tell the Kafka broker what is your address, because you can have multiple listeners in one Kafka cluster. That's where it gets really complicated to configure this thing, man. It's a beast, right? So we have to specify, and in this case, the advertised listener is just one, and that's the one we're listening to, 9092. So what it's called is Kafka underscore advertised underscore listeners, right? I know how to pronounce listener. I'm just being silly, guys, because that's how I learn English, by the way. I actually overpronounce all the letters because I don't know how they are spelled, right? That's why I have to say listeners. And you can laugh, it's okay. I won't be mad at you. All right, so here's the thing. So maybe just let's push some spaces here so we can just see that. All right, sweet, -e. Nice, listeners, we have all the listeners. So what do we do? Here's the thing. Kafka supports SSL and plain text communication, right? And for some reason, if you do plain, you have to do like plain text protocol, which is the encrypted version of things. And the other one is, I think it's called either TLS or SSL, I forgot. So because obviously you need to sometimes to do secure communication, right, versus unsecure. And how does the system know that this is secure versus unsecure? This is not HTTP, HTTPS, right? So we need a Kafka similar terminology. So plain text is the HTTP version, if you will, and then the other one is the HTTPS, right? But yeah, once you do that, I say, okay, where is your broker? And it is husseinmac. Guess what, guys? 9092, because that's what we send back to the consumers, so they can actually communicate with the broker. Okay. Sweet, so far, almost done, almost done. The final one, which really got me so many times, right, is this guy, okay? Kafka, you know, when we did ZooKeeper and all this replicated stuff, right, we copied the broker into a new instance, right? We spin up a 9093, right? Kafka by default, or ZooKeeper by default, spin up 3 instances by default, right? And if you don't tell, if I just now run Kafka just like that, it will assume you have 3 instances. I will get really confused and say, hey, I only see one broker. Where are the other 2? I'm sorry. It will die. So what are you gonna do essentially is force Kafka, hey, idiot Kafka, I have only one offset topic replication. So that's what you do. Offsets underscore topic underscore replication underscore factor, and you can say equal 1, right? Obviously, guys, you can skip through this, right? You can just copy and paste, but I like to explain what's going on with every single command that we put, right? And finally, guys, the image. And the image, for some reason, doesn't live by itself. It lives in this Confluent, which is the company that actually maintains this project, right? Confluentinc slash cp-kafka. And we're done. Let's see if we nailed it, right? So yeah, run it. And we'll start running and we'll check if the ZooKeeper is running and everything is good. And just like that, it will just subsequent, and we have a Kafka cluster spin and we have a ZooKeeper, right? We really don't care about ZooKeeper. It's going to be in the background, but we really care about this guy, right? And it looks like it's up. How do I communicate with it? husseinmac 9092. That's broker. That's how we deal with it. How about we write some code, guys? Let's just jump into it and write some code. All right, guys, I have Visual Studio Code here and I have Node.js installed. That's the only two pieces you need to do this tutorial, right? You already have Docker. We already spin up a broker, right? That rhymed. All right. So we're gonna now write our own first code to communicate with the broker. So let's start the project. How about that? We're gonna go ahead, open, go to JavaScript Playground, and I'm gonna create a folder called Kafka, and then just open it. It's a brand new project. And then let's spin up, let's initialize npm, guys, because we're gonna need npm, right? So let's do npm init-y. So that's a project called Kafka. That's pretty cool, right? So that's right. Now we have a package.json. Let's create a new file and let's call it topic.js, okay? And we're gonna create a topic. That's the first thing we're gonna do, okay? And to do that, to create a topic, guys, first of all, we need to require the library that will allow us to do the fancy stuff to communicate with the broker and Kafka. And that library is called Kafka.js. So I'm gonna create a constant called Kafka equal require Kafka.js, and then you can either do this, right? Or you can do the destructuring assignment, right? Sometimes I find this confusing. That's why I show you guys both, right? But I find this sometimes confusing, but this is exactly the same essentially. So whatever rocks your boat, right? So essentially this will give, and I made a video about destructuring assignment. I'm gonna reference that video. But it still gets me, right? Destructuring assignment sometimes in cases, it gets really confusing to understand it and it becomes readable. It's pretty to look at, but it's very hard, in my opinion. I might be just a bad programmer though. All right, so Kafka, we have Kafka as an object here. What we need to do essentially, the next step is do this. We're gonna create a function, right? And that function should call it, I don't know, run. Because this will be, since we're gonna deal with promises, we need to do an async function, right? And just do the jazz, try, catch, all that stuff, right? And then let's just do console.error in case of error, something bad happened. And then just do this, right? You know, the usual stuff. And here's what I want to do. We will create an admin, right? This is something we didn't talk about. To create a topic, you have to create an admin connection, right? And to do that, you can do this. Before we write any more code, the first thing, remember guys, what do? The first thing we do when we communicate with the broker, we need to establish a TCP connection. Is that right? That's what we need to do. How do we establish a TCP connection? It is very simple, right? So what we're gonna do is create a Kafka object here, and we're gonna create new Kafka object. And then this guy takes an object, okay? And it takes a Kafka object, but we're not getting any IntelliSense because Kafka.js is not installed. So let's go ahead and just install Kafka.js. So how do you do install Kafka.js? npm install Kafka.js. That's not hard. The moment you install it, now you should start seeing some sort of IntelliSense, which is very important. Here you go. Kafka config. Now what we're gonna do is essentially what do we want? What we're interested in here. When we create a new connection to Kafka, you have to tell Kafka what is your client ID. And this is just a string, and you can call it anything you want, like, I don't know, my app, right? And if you do that, will uniquely identify the client, right? The second information, and here's the thing, and when you do code, well, I tell you, right? There are a lot of other stuff, but we're interested in this guy, brokers. Very interested in the word brokers, not broker. And this is very important because since you're working with ZooKeeper, one broker can go down and the other can go up. So you can actually give the client multiple broker as an array, right? That's why you can have multiple brokers and you can give all of them, and then the client will choose which one to connect to, right? In my case, husseinmac 9092. That's my broker right there, guys. All right, so now we have a connection. The second thing we do is, since we're creating a topic, we need the admin interface to create topics, right? And this is how you get it, essentially. You do kafka.admin, right? And then the moment you do that, you will get back an admin object. So let's go ahead and just do admin equal this, right? And then when we have admin, now up until this point, we didn't really connect, right? Because we didn't really tell to explicitly connect. You can throw in some configuration to auto connect, but let's be explicit all the time. It's always better. And here's the thing. The moment you connect, right? This is a promise. And what do we do with promises? We await them because something can go wrong, right? So let's do like console.log. I'm connecting, right? And then once we make it here, we do console.log connected, right? Woo! How about that? Okay. So when we do that, now I'm connected. What's the next step? I'm going to create a topic, right? And how do you create topics? Very simple. Literally called create topics. And the reason it says create topics and not topic is for efficiency, right? Let's send all the topics you want to create and we're going to take care of it. And the moment you say create topics, you know this is a wire call, right? And a network call. And without looking, actually, I know that it's going to return a promise, so I have to await it, right? And then when we have that create topics, let's do let's see what it takes. It takes an option, so it's essentially a JSON object. And what does it do? It takes timeout topics, valid only, wait for leaders. I'm gonna leave all of them as default. I really care about the topics, which is literally an array, right? And an array of how many topics? I just need one, really, right? So you need to tell me what is the topic name here. And then what's the topic name here? I'm going to create a topic called users. And the next information here is how many partitions are in this topic. You can specify here. So that's called num partitions. Because I would have never remembered this without IntelliSense, really, guys. So you do that and it says, hey, it's 2 partition because remember, it's A to what? M and N to Z, right? So that's the topic. We can make this fancier a little bit and make it like take a parameter to create any topic we want. But we don't really care because we're going to run this once and that's it. Once we're done, console.log, done, right? Created successfully. And then finally, once we're done, we can disconnect and we can await this thing. And then once we're done, we can do like a finally here, I think. And then do what? Let's just process.exit because we good. All right. The last step is, I don't know if you see, but this is like a little bit lighter color. That means just you never called me, son. So let's go ahead and run this thing. So run, we'll run this, create a Kafka object with these parameters, pull the admin object, actually connect, create a topic. Once it's done, disconnect. Looks good. How about we run it, guys? So we can either run it from debug or really just run it from here. So zoom in. We do node. What was the JS file? I forgot. What did we call it? Topic.js, right? So we're going to call it topic.js. Boom. and connected, created successfully. We can take their word for it, but let's see if it actually works, right? So we know we created something here. So how about we actually start producing something, right? So the second thing we need to do is write a producer. Let's do a producer.js. And here's the thing about producers, very similar, very similar. So I'm gonna copy the whole code here, right? And here's the thing, I am going to remove this stuff, right? Because it's really, I don't really care about that, right? But here's what really differs about this. The only difference is instead of saying I want an admin, you say I want a producer, okay? And that's it. Let's call it really a producer for simplicity. And we're gonna connect with the producer, and we're gonna disconnect with the producer, and all looks good, right? But here's the cool part. The producer have a function called send, right? And when you do send, you can actually send a record, and the record is an object. And then in the object, you can specify which topic you want to send to. Oh, that's cool, right? And the moment you do that, right, what's the topic name, guys? The topic name is always called user. So I'm not gonna bother sending that as a parameter. Okay, so it's called users. And then the second parameter is called messages. Okay, and then since you can actually send multiple messages, that's why it's an array. Okay, that's nice. Okay, so each message will have an object. Okay, and what do we have here? We have the key, partition, value, right? You can leave these information empty, headers and key, right? I'm really interested in the value. What's the value of that message? The value of the message is, and here's the thing, I want to call it message, MSG, right? And I'm going to ask the user for it. How about that? That's even better, right? Const message equal process.argv sub2. Sub0, this is the arguments, by the way. Sub0, Scorpion, Mortal Kombat. Sub0 is the Node.js application. Sub1 is the file, which is producer.js. Sub2 is the first argument. So if I do like node producer.js and I say test, then sub2 is actually this guy, right? That's what that's why I did that, okay? So that will be test or whatever the user sends, right? And if I do that, I'm gonna send that message. And here's the thing, I want to actually specify the partition, right? So the partition is actually, let's call it partition. But how do I know which partition? Remember, guys, if it's A, what was it? If A to M is partition 0 and N to Z is partition 1, okay? So how do I can tell this? It's actually very simple. So const partition equal, you basically take the first character of the message, right? And if it's less than N, what does that mean? That means it's partition 0. If it's greater than N, else it's partition 1, right? So that's the ternary operator in JavaScript. So check that. If it's less, then obviously the first letter is less than N, then it's the first partition, otherwise the second, right? Simple stuff. We have a producer, guys. Okay, how about we test our producer? We do node producer.js and let's do a test. Ooh, created successfully. How would I call it? Sent successfully, right? And the next thing we forgot to do is actually we forgot to await this guy, right? Because it's definitely a promise. And let's do console const result, because this definitely returns a result, right? And let's do sent successfully. And then let's just throw in the result here. How about that? Right? Let's see what we get. I'm going to send it again. Object. Well, let's stringify it. See what we get. And There you go. We have topic name, users, partition, error code, base, append, and all that stuff. It will tell you what is the current offset. That guy we talked about, right? What's the error code if there's any, and which partition did we write to, right? How about if I write to Ali, right? That's partition 0. How about if I write to Zain, right? That's partition 1 because Z, right? And so on. We can start populating stuff. And you can obviously duplicate, right? Doesn't really care. These are not really users, but I'm testing, right? So now I'm position number 3, 0, 1, 2, 3, right? And then 3 in partition number 1, 3 in partition number 0, right? So the offset is unique essentially per partition. Okay, we have producer, seems to be working, but I really need to consume, guys. How about we consume? Let's write a consumer. Very simple, very similar. So I'm going to copy the code, consumer.js, then paste, right? And then I'm going to call this guy, right? So when we consume, right, we really need to consume a topic, right? So we know the topic we're going to consume. So I'm not going to specify, and we don't need to specify a message. Maybe we need to specify a partition to consume from, but that will change based on which group you are. So we don't really specify anything. We just run the consumer and will tell us what to consume. So how about that? Let's do it. So not producer, I want a consumer, right? And here's the thing. I want to specify here information here. And I want to specify the group ID. And the group here, any consumer that we spin is going to belong to the same group all the time. And I'm going to call the group, I don't know, test, right? And then we're going to get a consumer back, right? Then we're going to connect. That seems okay. And I don't really care about that. I don't really care about that. I'm not sending anything. I'm not doing any of that. We're still disconnected, that's sure. I don't want to disconnect also. I want to keep the consumer running, all right? Because what is essentially the consumer is doing is they do a long polling, and it will keep polling for messages, right? In a long polling manner. And we're going to talk about that. Sweet, guys. All right, so let's do this. So consumer.subscribe. That's how you subscribe to a topic, right? And essentially what you do is hey, what topic you want to subscribe to? Well, it's called users. And do you want to read from beginning even if you're a new consumer? Well, yes, sir, all the time. Read from the beginning, right? So you have an option as a consumer to read from the latest position and forward, like, or if you're interested to read everything, that's really up to you, right? But sometimes if the topic is so big and you really don't care about old messages, you can say false. All right, guys, now that we are subscribed to the topic, the next step is to actually run the consumer, right? And just keep it running and let it pull the topic for results, right? How do we do that? We do a function called run. And when we do that, run, there is a function called each message, right? It's a key, and you can pass the function, and we can call it async result function, and that function will get executed for each message you receive. And then essentially what we're going to do is just print the result dot you can print the result of partition, topic, and all that stuff, right? We're interested in to print the message, for example, right? Let's say, hey, received message, or just received message result.message.value, right? On partition result.message.partition. How about that? Let's just do that, okay? And here's the thing we need to do. We need to remove the process.exit. We can't just kill the process consume. We need to make it always running, right? Let's do that. Node consumer.js, guys. Come on. Joining the group. There you go. We received all the messages essentially. and this guy is still running. And you can see, right? I receive messages from partition 0, I receive messages from partition 1, and it's amazing stuff, guys. All right, so here's what we're gonna do. I'm gonna open terminal, right? A new brand terminal here. How about we do that? Yeah. And then we're gonna do a new tab and also a new tab. And this will be my producer, right? So JavaScript, JavaScript Playground, Kafka, and then you say Node, right? This is the producer. And this guy, I want it to be the consumer. So how do we do a consumer? See JavaScript, JavaScript Playground, Kafka, and then just do node consumer.js. Wait for messages. And this guy is a group test, right? So start joining the group. That's cool. And now join the group. There are no other consumers, right? Now it is responsible for both partitions, right? So here's what I'm going to do. I'm going to go here and then go node producer, and let's say test. I just published something. Immediately, we got a result here. Hey, receive message on partition 1. Well, how about I'm going to do something on partition 0? Ali, right? That's partition 0, right? Message partition 1. That's because it's lowercase. Let's do it capital, right? I didn't take into consideration the lowercase, so that should do it, right? So now, receive on partition 0, right? So, Barbara, also partition 0, right? So this guy is responsible for both partition. How about you go here and say, first you need to go to the JavaScript, Kafka, and then node consumer. Join the group, sir. Now, this guy joined the group. He will be responsible for the other partition. I have no idea how they're gonna ZooKeeper, how they're gonna balance those, right? But this guy's one partition, this guy's another partition. Let's find out who is who, right? Node producer. Let's publish Ali. So that's or Adam. Adam's partition 0. We come here. We received Adam. So this guy's partition 0, right? Let's publish again, Adam 1. All right, we still got it here. This guy did not get Adam because he's responsible for partition 1 apparently. So let's do partition 1. Zain. This guy did not get it, right? But this guy got it, right? And now you can start just doing a for loop and just produce a lot of messages. And let's just do Zain 2, Zain 2. Look at that. Can produce as much as possible, and those guys immediately will get it because they are subscribed, they're running, they're consuming stuff, guys. I'm gonna make this code available, guys, for you. You don't have to pause the video and look at that, but essentially all the code is available in the description below. Let's go finalize this course, guys, by talking about the pros and cons. Almost done, guys. Almost done. There's a lot of stuff. This statistic is amazing, guys. So let's talk about a little bit about the pros of Kafka. Okay, Kafka is an amazing technology, right? And there's a lot of advantages to it. And the first one, I want to talk about the append-only commit log. This is at the heart of Kafka. All the partitions, all the topics, every message you write, it goes to a log, and that log is append only, right? So it always goes in the end. And if we know anything about computer science and computers, they thrive on appending stuff because it's the best. You go to the end, it's right there. You know where the end is. First, that's the first thing. You always know where the end is. You can go very fast to the end, and you can append extremely fast to the end, right? You're not seeking to the middle and you're inserting data between two blocks of data, right? Unlike relational databases and B trees, right? You're not doing that. You're not manipulating the actual disk space and fragment the stuff. It's always append only. That's why there are special SSDs that you can write once to and that you can never delete to, right? So that's what Kafka does. A lot of databases, by the way, do the same thing. right? They always have the append commit log where any event you do, anything, any insert goes into this append log first, committed. Like Cassandra works the same as well. And then what it does is essentially you create all this logical tables and all that other stuff materializes differently for you, right? So that's how they work. Kafka works like that. So it's very fast. The performance is amazing with Kafka because you're always commenting, and when you read, you know what you're gonna read. And they are very fast. They are very fast and indexed because we work with positions and partitions, and that's it, and append logs. So seeking to a position is extremely fast because, hey, I want to go to sector 5, block 7 on the disk, go there, right? And immediately pull that data. That's easy because that's the input. So the consumers a little bit suffer because they have to figure out which position they want to read from. But you cannot, the disadvantage of this, you cannot do like a select star or from topic where ID equal this. I mean, maybe the new SQL, Kafka, whatever they call it, has this. I think it's called Kafka SQL. Have this ability, but at the heart of it, it's an append commit log only, right? Append only commit log. So that's how it's very fast. You can read fast, you can write fast because it is designed for events, right? An event happened, a video has been uploaded, a video has been compressed, something happened. You go to the append, and the events do not change, right? If you do something, you cannot undo it, right? In real life, it's done. And that's how Kafka essentially works. I've been doing that. So performance is amazing because of that. Distributed with ZooKeeper, right? Well, with ZooKeeper, the concept of partitions was still, it's an append log, right? It's an append commit log. You can distribute this partitions, and you can have one leader partition, and you can always write to that one, and the rest of the partition will follow that, and it will get copies of the latest information and latest messages, right? So it's very distributed, and because of the design, because they're sharded, these partitions, they can very easily distribute these things around, and you can easily scale as a result. Long polling. I want to talk about that a little bit. So RabbitMQ, I made a video about RabbitMQ. I'm going to reference it here. And essentially what RabbitMQ does when it tries to send an information to a consumer, it actually uses the push model, and it can because it's a TCP connection. Even Kafka can do that, but it doesn't, right? And the limitation of the push model is the consumer cannot really consume as fast as producers most of the time, because you can have producers like Gary Vee pushes content like 700 videos a day, right? And we poor consumers cannot consume any of it, right? Barely consume any of it. So if you stop pushing information, consumers do not have the cycles to consume that stuff with push model. So Kafka flipped it. It says, hey, let's use the polling model where the consumer asks for a message, but we don't want to do a dumb polling model where consumer says, hey, do I have a message? 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 No. Here's the criteria for long polling. Give me a response. Hey, is there a message? And don't respond immediately if there isn't any messages, right? Don't tell me, hey, there isn't any messages. Wait for X amount of time. And by the way, if the message, if there are at least 7 messages, push them to me. Or if there's at least 700 bytes of messages ready for me, push them for me. If there's only data available, push it to me. Don't send me empty responses, essentially, right? So that's essentially what long polling is. You make a request and you wait for it, right? So there's no empty misses, right? There's no miss of requests. So you make a request and you find out that, hey, there is nothing. And these are very harmful. If you make requests that saturate the bandwidth, right, and consume CPU cycles, both from the server and the client, right? So long polling, on the other hand, whatever we did, right? We ran the consumer, and the consumer started doing the long polling behind the scene. It's all the Kafka JS in this example, which is an amazing library, by the way. It does the long polling for us, right? And I'm gonna make a video just separated just to talk about long polling. So it's an event-driven architecture. It's a pub sub and it's a queue, right? All at once, right? It's a queue because you can put all your consumers in one group, and each group, each consumer will receive one and only one message. No message will be received by other consumer, which is, that's what a queue is, right? It can be a pub sub, a broadcast message. Hey, I uploaded this video. Please, consumers, consume ahead, right? Go and check. The copyright service can consume that stuff. The caching service can consume that stuff and cache the stuff. The content ID can consume it. The codec service can consume it. Other services can consume it, and they can do stuff. So the same message can be sent to multiple consumers, and you can do that by creating consumers with different groups, right? Because if you do that, we essentially send a message for per each group. The message is a group dependent thing. Okay. And it's also event driven, and a lot of people use microservices with Kafka, right? And the reason they do that is like Kafka is kind of work naturally with microservices, because instead of microservices talking to each other, since everything is like almost like event driven, hey, a video has been uploaded. Hey, a video has been compressed. Hey, a video has been copyrighted. Hey, a video is ready to be edited. Something like that, right? So all these are events. You can store the events in Kafka and listen to those events as a consumer and do something with it, right? So you can have everything as an event driven. Oh, when something happened, do this. When something happened, do this. And instead of having to do this logic in your application, which kind of gets complicated. Obviously, it scales like there's no tomorrow, right? Because just spin up another broker and you're done, because ZooKeeper will just pick it up and will understand that stuff. Parallel processing, if your consumers in one group, then you can just shove, just consume. There's no tomorrow, right? Because all of those consumers will hit that list of partitions in parallel. So one topic, multiple partition, you can read them in parallel. If there was no partitions, you cannot do that. You have to sequentially read the log. But because now I use sharding, I sharded my data, I now can consume in parallel data. The problem with this is, as a producer, it sucks for me. Now I have to kind of know the partition, which kind of sucks, which kind of complicates the application a little bit. Cons. This is the biggest hurdle. And I think the community is working on, I think I read somewhere that the community is working on removing ZooKeeper as a dependency from Kafka. I might be wrong, but I read a couple of places. I forgot where I'm trying to find the article. I'm going to reference it in the description below. But ZooKeeper, I haven't worked with ZooKeeper, to be honest, right? So I'm not an expert in this technology, but I heard a lot of people, engineers, complaining about this, especially at scale. If at scale, it behaved really weird with microservices. A lot of people use ZooKeeper as a service discovery mechanism. It says, hey, tell me where is the service discovery service that I need to communicate with it. And if it's down, it brings the entire system to its knees. And that's bad, right? Because you kind of relying the entire system on this piece of technology. And if it's down, oh my God, things can go wrong. While I was making this video, ZooKeeper started acting really, really weird, and I had to restart it several times. And this is just with single broker, right? I didn't make a video yet to make it multiple broker, and it's really complicated, right, guys? So ZooKeeper kind of complicate things, and scaling becomes, maintenance essentially becomes really hard. And I can also add the consumer to this, but producer essentially having the knowledge of which partition to publish to, right, can lead to problems because now you have the complexity of knowing the partition. And we have the same problem today with relational databases sharding, right? Because the moment that you start sharding, hey, you have database 1, 2, 3, 4, 5. Well, I want to read user 7. Where the heck should I query? Which database should I query? Is it 7, 7, 8? And you have to know, oh, by the way, you have to keep the ranges, the partition key they called, or the sharding key. You have to know, this user is actually on this database, so I better connect to this server. And yeah, it's very beneficial, but it complicates the clients. That's why there's another software called Vitess, I think. And Vitess abstracts the sharding from you as a client and takes care of the sharding and auto sharding, resharding, and just make a query and it will does everything for you. And I think it's running on MySQL. I think YouTube actually uses it, Vitess. That's what it's called. I'm gonna reference it in the description. Complex to install, configure, and manage. It took me a whole day to figure this out, guys. The video I made for just to spin up one broker and one ZooKeeper took me a whole day, right? Just imagine how do people do multiple brokers? I know there are like scripts that you just run and just take care of everything, but I really didn't want to do that for you guys. I didn't want to download like a compose Docker thing and just like, hey, just download this and run it. I didn't want to do that. I wanted to understand what's going on. I think this is on me really. I just do not like to copy and paste code. I don't like to show you things that I don't understand because I owe it to you guys. If I'm explaining something, I need to understand it, right? Obviously, I'm not gonna show you, hey, take this YAML and then just run it and it's gonna do everything for you. Maybe I'm gonna do it if I understand the things, but that's why it slows it. That's why it takes me a while to make videos because I really need to understand every single piece, right? And a lot of technologies are like that. So you need to understand everything. That's why I try to isolate everything and make the setup as simple as possible. But believe me, if you go there, I could not find those two lines of code that spin up a ZooKeeper and Kafka cluster as a single. I could not find it. I swear to God. Right? That's why I had to write it myself. I have to understand what's going on, and essentially I do it, right? The rest of the stuff are very complicated, and I wanted to make it as simple as possible. Summary, guys, a huge video. I know. All right. So hopefully you made it to the end. Write in the comment section I made it to the end. Right, if you did, I really appreciate it, guys. Hope you really enjoyed this video. So essentially we talked about Kafka Components, we talked about the brokers, right? We talked about partitions, we talked about producers, consumers, right? We talked about ZooKeeper. We talked about we did an example where we spin up a Kafka cluster, a ZooKeeper, all that jazz. We wrote a producer and consumer with Node.js. We show how the load balancing is done. We show how the rebalancing in a group is done and all that stuff. We talked about the pros and cons of Kafka, right? Hope you enjoyed this video, guys. All the resources will be available in the description below. Hope you enjoyed this video. I'm going to see you in the next one. You guys stay awesome.